Okay, welcome in the second part of this lecture. Actually, epidemiology of and pathogenesis of Haemophilus of Bordetella, is very high, and it's about 51 million cases per year, and the mortality rate is relatively high, about 600,000. This occurs per year. Actually, the target age for Bordetella is the younger children. Those ranged years from 1 to 5 years. Bordetella pertussis involve different virulence factors. Those factors that characterize this bacteria to lead to some diseases or to some pathogenesis that characterize this disease and characterize clinical features of pertussis or whooping cough in the 3 stages that we will mention now. Those virulence factors involve pertussis toxins, very specific toxins that related to destruction of ciliary tissue, tracheal ciliary tissue. Some other toxins like adenylate cyclase toxins that related to edema or release of release of fluids, water outside tissues, and some other tracheal cytotoxins that related to direct cytotoxicity to tracheal ciliary and tracheal cells. Actually, there is specific type of proteins that facilitate attachment of bacteria and lead to biofilm formation, which is called filamentous hemagglutinin, which is a specific protein that covers the surface of bacteria to facilitate the biofilm formation. In addition to agglutinogens that lead to some immune response, some very huge and exaggerated immune response. Actually, there are 3 stages of this infection. Those 3 stages are varied in their period of times. The first stage is asymptomatic, as usual in other infections. Usually lasts for about 3 weeks, from 1 to 3 weeks. After that, the second stage or second phase called catarrhal phase, because they characterized by catarrhal characters or catarrhal symptoms like rhinorrhea, malaise, mild fever, and cough, and so on. After this period of time, that maybe lasts about 4 weeks to 6 weeks, after that, the patient will go through the last stage, or actually it's not the last stage, because we have the last stage is called convalescence stage. So this is the illness stage. We can consider it as illness stage, or called paroxysmal stage or phase, at which the cough worsening, and the main feature of this disease revealed as whooping and called whooping cough because of whoop sound. The whoop sound that generated from difficulty of difficulty of breathing and trying to gasping air lead to this characteristic sound called whooping. That accompanied also with cyanosis because of difficulty in breathing, dyspnea and apnea and vomiting, and sometimes suffocation of child, very dangerous and life-threatening infection. How to identify this infection? You can identify it in laboratory, in microbiological lab, by diagnosis, by clinical diagnosis first, by clinical diagnosis of paroxysmal stage, which is highly characterized by a specific and characteristic sound called whooping cough, and also the existence of colonies or ability to grow in a specific media called Gengo media, or another type of media also involve antibiotic that inhibits all types of bacteria except the Bordetella called Reagan media. The existence of pinpoint colonies on this selective media is very characteristic and can be used for identification of volatile pertussis. Also, we can use serological identification by identify antibody or by reacting a specific antibody against bacteria in addition to or combined to fluorescence. The drug of choice of this disease is erythromycin. In case of resistance, we can use cotrimoxazole, which is sulfamethoxazole and trimethoprim. The prevention, we can predict the prevention. If we know how transmission occurs, we can prevent the disease. This disease actually can be prevented by vaccination, and very common vaccines, all of us know that the common vaccine or triple bacterial vaccine called DTP, diphtheria, tetanus, pertussis, one of the most important and basic prevention way for prevent this disease. The second example of aerobic bacteria, aerobic gram-negative bacillus called Legionella, which refers to Legionellacea, a specific family of bacteria which is actually, and this is the first gram-negative aerobic bacteria, is intracellular parasite, facultative intracellular parasite. It means some of bacteria can exist inside cells and outside cells. Most of Legionella can lead to respiratory tract infections. Also, we can find this bacteria in some clinical materials as a Coccobacillus, and also this type of bacteria also characterized by the requirement or the requiring a specific type of nutrients like the amino acid cysteine. The most important species of Legionella, which lead to the most or the majority of infections or clinical problems, called Legionella pneumophila. Legionella pneumophila, and we can calculate the infections that caused by Legionella pneumophila, pneumonia or respiratory infections. So the mode of transmission for Legionella is through inhalation, through airborne infections, through airborne particles, and sometimes Legionella also transferred through swimming pools or swimming water. So the disease can be manifest in 3 different forms: the Legionnaire's disease, Pontiac fever, and non-respiratory infections. Actually, Legionnaire's and Pontiac fever are usually characterized or transferred through airborne, and non-respiratory disease transferred through contaminated water. The identification of Legionellosis, disease or infection of Legionella, we call it Legionellosis, can be characterized by X-ray of lungs and gram stain, and also there is a specific type of stain called Guyman's stain. This type of stains is very characterized or highly characterized the Legionella bacteria. We can use also specific selective media, usually involve charcoal and yeast extract and L-cysteine, because this is the requirement, the highly required nutritive for Legionella, in addition to iron and ketoglutarate. Also, we can identify it by serological antibodies, by interacting with specific antibodies against Legionella, or radioimmunoassay, or DNA probing, which is very accurate, by fingerprinting of DNA of Legionella, which is highly effective and highly accurate. We can treat by any type of macrolides like azithromycin, clarithromycin, erythromycin can be used for Legionnaire disease, or other infections like water transmitted infections. We can use ciprofloxacin or ofloxacin for this type of infection. The second type of non-enteric bacteria, non-enteric rods, that is, those bacteria that involve some opportunistic bacteria. For example, Pseudomonas. Pseudomonas is one of the ubiquitous organisms. It means that it presents or exists in nature, in soil, in water, in plants, in animals. You can find it at anywhere. So Pseudomonas involve different species. One of the most important species, one of the most pathogenic species, actually involved in different types of antibiotic and multi-drug resistance infections called Pseudomonas aeruginosa. Pseudomonas aeruginosa is characterized by specific characters, by general characters like motility, like encapsulation, because they're able to do or to synthesize biofilm. Also, Pseudomonas aeruginosa can be found in different facilities in laboratory, like laboratory water baths, especially the hot tubs or hot places or hot storage of water. We can find it. We can find it anywhere filled with water or wet places. So usually Pseudomonas aeruginosa accompanied with nosocomial infections, with hospital-acquired, nosocomial equal to hospital-acquired infections. The hospital-acquired infections that are related to using of water, using of sinks, like as in case of burn infections or burn wards, burn patients. Those patients are suffering, highly suffering from infections or repeated infections of Pseudomonas aeruginosa. Pseudomonas aeruginosa are also characterized by highly characteristic character, which is the release or the ability to release a specific dye called pyocyanin dye or pyocyanin stain, which is greenish, bluish or bluish green color or pigments that produced especially in nutrient agar. You know that nutrient agar is ordinary growth media, can be used for a lot of organisms. The highly characteristic feature of Pseudomonas is ability to release pyocyanin in the nutrient agar. The pathogens of virulence of Pseudomonas aeruginosa. Why Pseudomonas aeruginosa is very virulent in most of cases? Because of some virulence factors, some features, some traits, some characters. Those characters enhance the pathogens of bacteria. For example, the existence of villi. We know that pillas or villi are tube-like structures used for adherence, used for conjugation, and usually it's used for adherence of this type of organism in different surfaces and lead to different pathogens. We know that a lot of pathogens is connected with biofilm ability formation. And also the glycocalyx capsule refers to their ability to adhere and also ability to antagonize the cleaners, the innate mechanisms of the immune system, like phagocytosis. It can stand against phagocytosis. In addition to different toxins, for example, lipopolysaccharides, as you know, it's gram-negative bacteria, extracellular toxins that lead to or that facilitate invasion of bacteria and disseminate to other organs, to other tissues, and also protease-specific enzymes, protease, elastase, those enzymes that are able to destruct or destroy proteins, hemolysis, phospholipase, and pyocyanin stain. Actual pyocyanin, we can utilize pyocyanin, the pigment, the bluish green pigment, to characterize the organism. Actually, this type of organism, this aeruginosa, can stand against phagocytosis as innate immunity mechanisms, endotoxins, exotoxins A and S. All of these toxins are highly immunogenic and lead to very strong immune response, which is reflect the pathogenesis and the disease occurs by or produced by aeruginosa. Pseudomonas aeruginosa can be involved in two different infections, either localized infections or surface infections like Lyme infection, keratitis, and swimmer's ears, which is highly connected to swimming. Those people used to swim for very long time in swimming pools. And as I just mentioned, the Pseudomonas aeruginosa is a marine organism, exists in water most of the time, usually exists in water. And sometimes some of my students can say that we are using disinfectant, we are using Clorox, for example, or chlorine to sanitize swimming pools. Why Pseudomonas aeruginosa exists in these media, in these type of places? The answer is this type of organism, Pseudomonas aeruginosa, actually is highly resistant to chlorine. It can build up a resistance. It's easy to accept or easy to develop a resistance against a lot of disinfectants, including chlorine, including phenols, phenolics, alcohols, and so on. So it's usually this type of infection can extend to respiratory tract infections, can extend to CNS to lead to meningitis, especially in patients with low immunity, in elderly, in child, and so on. Infections also can be more severe, more disseminating, as in case of bacteremia in immunocompromised patients, in pneumonia in some patients, specifically patients with immune problems like cystic fibrosis, patients, sometimes disseminating to bone and joints, especially in diabetic patients, those patients with low immunity, endocarditis, CNS infections, and soft tissues infections. Actually, lab identification involves the culture of organism in blood agar, and also in some, they can grow also in McConkey agar, and also they can produce very characteristic pyocyanin pigment, as we see here in this nutrient agar, very ordinary media, can produce bluish green dye or stain, which characterize this type of organism. Also, the very characteristic smell, grape-like smell, characterize the culture of Pseudomonas. We can also identify by multiple tests, biochemical tests and serological, also by interacting specific antibody against surface molecules or surface components of Pseudomonas aeruginosa. Actually, the antibiotic resistance is highly exists in Pseudomonas aeruginosa. So it's not easy to treat this type of infection due to the highly resistance. So usually, in order to overcome the resistance, to overcome this virulent organism, we have to use 2 or 3 antibiotics to overcome the resistance. Usually also we accompany this treatment with anti-Pseudomonas, beta-lactam, like carbaminoids, to treat the infection by Pseudomonas. How to prevent? You can predict the prevention of this disease. Actually, pathogenesis of Pseudomonas aeruginosa refers to high ability to produce or to develop antibiotic resistance. So in order to overcome the antibiotic resistance, we have to follow up or to adhere to specific strategies to overcome the antibiotic resistance, especially at hospitals. In hospitals, we can use, for example, antibiotic cycling strategy. You have to cycle the antibiotic. You have to avoid using of the same antibiotic for very long time. And also you have to remove the catheters, intravenous catheters. The recommended period of time, 48 or 72 hours, to avoid the infection by Pseudomonas. This is highly characterized, cultural characteristic of the Pseudomonas on mutant agar, which is Penicillin pigments. The last category of non-enteric gram-negative bacteria involve zoonotic infections or zoonotic diseases. That include Brucella, Francisella, Pasteurella, Yersinia pestis, and Bartonella. Brucella refers usually accompanied with specific infections transferred from cattle and from livestock like sheep, cows, and so on, accompanied with Malta fever, Humma al-Maltiyya, or Andolan fever. This refers to the same features of the same clinical manifestations called brucellosis. It's a zoonotic disease because the main reservoir of this infection is animals, or definitely, certainly, the cattle. We can characterize Brucella by their aerobic ability. Facultative intracellular parasites, they can exist in both inside and outside cells. But the most characteristic feature of this bacteria, they can involve inside the phagocytes. So this is one of virulence. They can grow inside phagocytes. So phagocytosis will not be effective in this type of bacteria. Some genus of Brucella are unencapsulated. They are usually present in pairs or singles. The major or the most important external virulence factor is lipopolysaccharide. Usually, as we just mentioned, the main reservoir of this bacteria is livestock animals, and especially in reproductive organs, male and female, milk, urine, placenta. So the main transmission occurs from animal to humans through direct contact with animals or by ingestion of unpasteurized milk or unsanitized meat. The pathogenesis of this bacteria refers to either abrasion skin, transmitted through abrasion skin, or through ingestion through GI. Also, they can transmit or disseminate from the site of infection, the site of entry, from either abrased skin or intact skin or GI. They can disseminate through the circulatory system and go through lymphatic system, and from lymph nodes they disseminate to other and multiply to other parts, and using the utilized blood to go through or to transfer to other organs like liver, kidneys, bone marrow, and lymph nodes. So we can see brucellosis as diffuse disseminating infections. Actually, at the beginning of the infection, which lasts about 5 days incubation period, asymptomatic, and after incubation period, which is usually asymptomatic, other symptoms abruptly, suddenly occurs, like flu-like symptoms, and sometimes include depression. If the patient is untreated, the undulant fever starts. The undulant fever means rise and fall, rise and fall, rise and fall. So we call it undulant fever. It's highly characterized, this type of infection. How to identify? We can identify brucellosis or brucella by taking the history of patient. Actually, this is very important. because some of infection features confused with other features with other infections. So it's very important to know the history of the patient, the occupation, the contact with animals, the ingestion of animals, the nutrition habits. If patient, for example, utilize unpasteurized milk and so on. This is very important. And other diagnostic features like antibody serological testing, which is highly accurate and can be used and can be quickly give us a result or a specific accurate result for brucellosis. The treatment relatively long, lasts for long time, not less than 6 weeks. A combination of doxycycline, for example, plus gentamicin or streptomycin.